select object 1, shift to select object 2, and go to constraint, point constraint, maintain offset, reset the tool. So if it is not maintaining offset, what will happen? We will see. We will just apply. Yeah, again it is going back there to the position. So we need to give maintain offset and give apply and close. See what we have given here. Point constraint will only affect the translate values. Okay, so that is what happened here. You can see the child. Okay, after we have given the point constraint, when selecting the secondary or second object, you can see only the translate value is being affected. You can see the blue color. Translate XYZ is only being influenced by this object. Okay, so if I move, it will move. The child also will move. But if I rotate, okay, the child will not respond. So this is the purpose of point constraint. Okay, now similarly, let us see what is the orient constraint. Yeah, I'm just again removing all the inputs, right? Again, I am coming to make sure you don't have any inputs. Yes, okay, select this object, object 1, shift select object 2, go to constraint, go to orient constraint, maintain the offset, give apply and close. You can see the influence in the child or the secondary object. Only the influence is on rotate X, Y and Z. See, now you can move it. Okay, but there is no change. But if you rotate it, you can see the influence. Okay, orientation is rotation. Okay, orientation means rotation. Okay, orient constraint, right? And one more thing. So this is parent constraint, point constraint, orient constraint. Yeah, I will explain the scale constraint. It is very easy. I hope you can guess easily now what is the scale constraint. Okay, making all the values 0 again. I'm just select the main thing, shift select the second thing, go here, scale constraint, maintain offset, give apply and close. Now it will not move, it will not rotate, and it will respond in no way other than the scaling. If I resize the object, it will affect. Okay, that is the purpose of scale constraint, right? Before explaining the aim constraint and pole vector constraint, I want to clear you one particular thing, one small thing I want to make clear. Okay, see, we will remove all the constraints. Okay, give Control Z and go back. Okay, now there is no connectivity, no constraints. Okay, I will show one small demo, a small difference between the parent-child concept and constraints. Okay, so select the object 1, shift select the object 2. I am giving parent constraint. As usual, it is clear. You can see translate XYZ, rotate XYZ. What happened in parent-child concept? The child may move somewhere. Okay, the child, okay, it can be somewhere else. But when the parent moves, it moves along with it. But this is in parenting. But when it comes to constraining, okay, constraints or constraining, the child can move, okay, but if the parent starts to change its position, if the parent starts moving, the child should take the 0th position. The child, wherever it is, it should come back to its original position, and from there it will start responding to the parent. So this is one very important aspect which we need to keep in mind, because when we are doing rigging, when we are rigging a human body or a bone and skin setup, a bone should be inside the body. Okay, consider this is the bone and this is the skin. Okay, this is the bone which should be inside the body, okay, which should follow where the body goes. Okay, so just keep in mind. So that is why constraints are different when compared to the parent-child concept. Okay, now I hope you understand the difference between, the major difference between parent-child and constraint. Now I want to explain another constraint which is called aim constraint. Okay, aim constraint. So I'm just selecting this, I'm just giving the global value 0. Yeah, I want to remove all the connections. Okay, I'm just going to simply, I'll go to outliner and I will delete the constraint, the connectivity. Now both the objects are independent. Now I'm going to give aim constraint. Let us see what happens. Select the object, shift select the second object, constraint, aim constraint. As usual, you should check maintain offset and give apply and close. Now what happens, the rotate, it got influenced, but it is different from orientation. Okay, see, the difference is not clearly visible here. It is like we should have to give what more in detail connectivity to get output in this regard. It is like if I move this parent, okay, the translation of this parent affects the rotation of this child. Okay, previously in orient constraint, the rotation of the parent affect the rotation of the child. Now in aim constraint, the child is aiming the parent. Okay, the child, just imagine the child looking at the parent. Okay, so the parent is going up, the child is also looking to the parent, right? So that is why the translation of the parent, it is affecting the rotation of the child. Just imagine this is the face of the child, okay, looking at the parent. Okay, so this child is aiming at the parent. Okay, this is the person who is aiming and this is the target now. Okay, so when I am moving it, it rotates, the child rotates. I can explain you why it is needed, this kind of constraint. What is the need of this aim constraint? Because Because it is having cross connectivity, translation and rotation, the connectivity between translation and rotation. What is the need? Practically, when in rigging, I will explain where it is needed with one simple example. Like you can see the human rig what I am having. You can see this human rig what I am having. Okay, this is a human rig what I am having. Okay, right? This is the curve. This curve is attached to the eyeball. Okay, we cannot directly touch the eyeball and animate. This curve is a representation of this eyeball, and this curve is connected to this curve. Okay, so in this case, what happened, what is the connectivity given is this curve acts as the child and this controller curve acts as the parent, object 1 and object 2. Okay, so this and this are being connected with aim constraint. Okay, so if I select this object and if I move this object, you can see the eyeball movement. Okay, so practically this is the purpose of having a separate constraint called aim constraint, right? If I want to focus somewhere, based on that focus I want to move my eyeball, then that focus should move. Okay, so that is why we are having the aim constraint. The character is aiming here, so practically this is linked to this. Okay, I hope you understood the aim constraint. And one more last constraint is the pole vector constraint. Okay, this is the pole vector constraint. Pole vector, what is this technical term called pole vector? Okay, no need to go too much technical, right? Okay, we need to know the purpose. What is the purpose of that constraint? We need to know that purpose. Okay, again I'm coming back to the human, right? I'm taking this human rig. Okay, there is something called IK handles. Okay, in your upcoming topics we are going to see about joints and bones, rotation axis, IK and FK. So IK is a handle, it is also a rigging technique. Okay, so in that IK handle, any IK handle can be applied between the hip joint and the ankle joint. Okay, so that we can achieve this kind of action. Okay, you can see this shape. To gain this action, we need to apply IK handle for legs and hands. Okay, so wherever IK handle is applied for a human or anywhere in an organic model, okay, not an inorganic model. Okay, even in inorganic model it is applicable, but in our example we are having organic model. Okay, there comes the pole vector. Okay, see, if I want to move this arm, I can move, I can fold. This is using IK handle. Okay, I will explain what is IK handle and all these things. Right, you're going to rig a character like this. But how do I move this elbow? That is where it comes the pole vector. Okay, see here there is one control. Okay, with the IK handle which is present inside this hand, which is being connected to the bones of this hand, that IK handle is selected and given with the constraint called pole vector constraint. So that pole vector constraint acts like this. Okay, this is the controller curve. Select the IK handle, give pole vector constraint. Okay, that we will practically see when we are doing rigging in the next class. Okay, so now I will demonstrate how it works. I'm selecting this pole vector and I can use it to move the joint which is present between two bones. Okay, this is a joint. Okay, this is a joint, this is one bone and this is another bone. So to move or to rotate the joint which is present in between two bones, okay, that is where we need the pole vector constraint, right? Pole vector constraint. Okay, so I want you to go back and play back. So I want you to practice the parent-child concept and all the constraints, okay, and get very clear knowledge about these two concepts before we are getting into the other contents like joints, bones, and IK, FK, and everything. Because once if you are clear with these concepts, only then we can get into the other topic. Okay, now we're gonna see what are joints and bones. Open Maya. See, I'm just changing my tab into rigging tab. Okay, by default it will be in modeling tab. I'm changing my tab into rigging tab. Then you can take the shelf with the name of rigging. Okay, choose the shelf with the name of rigging and double click on this tool. This is the joint tool. Okay, double click on this tool, reset the tool before creating a chain of bone structure using joints. Okay, whatever the tool we take in rigging, before that we should reset the tool. Okay, I'm closing it and you can see in this key points what is the explanation given. Joints are transform nodes which are connected by bones. By last class itself I have told what are nodes. Okay, right? Then joints are also kind of nodes which are connected by bones. Say for example, I have taken this tool, did reset, and I'm going to create a joint. I'm just simply, see, I'm just coming in front view. Okay, I'm just going to simply click. Okay, that's all. Give enter. This is a joint, but this joint do not have any continuity or connectivity. Okay, this is a single joint. Okay, from this joint we can create bone structure. Okay, that I will explain. You can see this joint, you can see the joint name as 1, right? Okay, joint 1. Okay, and a joint can exist a joint without a bone can exist, yeah, and can be skinned with the mesh. We will see what is skinning. A joint without a bone can exist. It is a single joint. Okay, there is no bone structure. Now a bone cannot exist alone with a joint node. Okay, because bone is the connector between two joint nodes. So I'm just going to delete it. I'm going to show what is a bone. Again I'm taking a joint. I'm clicking here. Again I'm clicking here. Again I'm clicking here. Coming to right view. Again I'm clicking here. Again I'm clicking here, giving enter. Okay. So can I assume this is a leg, either left side or right side? Okay. Assume the structure as a leg. Okay. This is hip, this is knees, and this is ankle, and this is the ball roll. We used to say it is the ball, B-A-L-L, ball roll. Technically we will come to know what is that later. Okay. And this is the fingertip or the tip toe, right? Okay, see, don't get confused. Okay, what is ball and all these things? I'm just telling hip, knee and ankle. Okay, keep these three things in mind. See, this is a hip joint. This is a node. This is also a node. Okay, see, you can see joint number 2, right? But what is the bone? This is which is in between two joint node, that is called the bone. Okay, what is the purpose of the bone? Is to take or to carry the influence. Okay, the influence of this joint starts from this area and ends this area. Okay, from here joint number 2 has been created and it takes control, and the influence of joint number 2 starts from this area and travels up to this point. Okay, now there another joint is created. Okay, so what is the purpose of a bone? A bone is to connect and act as an element which carries the influence or which finalizes the boundary of the influence of any joint. Okay, this joint starts here and it can control up to this place. Okay, this is the hip. From there I will be having one bone joint through the knee, because if I want to bend my knee, I should have a connectivity here. Okay, I should have a, see, this is how I can bend my knee. Okay, this is my hip. This is the root actually. Okay, this is the root. Hip is also called the root because where we start to create our joints, from there the other chain of joints are traveling, and where it ends, that starting point is called as the root node. Okay, this joint is a root node. Okay, this is my hip. This looks mechanical. Okay, but see, now this is my knee control, and this is my ankle control. Okay, so this is one very basic structure of human leg bone joints. Okay, so I hope you understand the difference between joints and the bones, and the purpose of what is the purpose of joints and what is the purpose of bones. Joints are to create a starting point or create an intersection wherever we need the character to bend or rotate or transform, right? So this is how I can rotate. If a human being, just imagine, I'm giving another example, I'm taking another joint tool. See, whenever you are creating a joint or bone, do it in straight view, do it in front view, or do it in side view. Okay, don't do it in perspective view. See, if I want to create a joint like this, okay, I'm just clicking here and clicking here and clicking here. Okay, if I give enter, see how it has been created, right? Can you understand? So now I just want to delete this. I'm just going to create another bone structure to give you more clarity that why you need the joint here. Told you, right? This is the knee. Okay, so what if I don't have this joint, right? I will take the joint tool again. It is already reset, so no problem. Again, I'm coming to right view. Here I'm going to create again one more hip joint, and directly I'm coming to ankle, and directly I'm coming to toe. Okay, just imagine which one looks more like comfortable, like a human being's leg structure. This one or this one? This one, because wherever I need to take a deviation, wherever I need to take a rotation or movement or translation in the chain of a skeleton structure, there I will end the bone of the previous joint, then I should click for another joint, again I should start creating another bone, right? So that is the need of creating multiple joints. Okay, so this is not how a human leg is going to work. Okay, even this is having the same function, but see, this is flexible. Okay, this looks like more like human legs, but see what happens here. It is like not even a robot leg, it is like a wooden leg or something. It is lifeless. So I hope you understood the difference between joints and bones. Okay, next topic is rotation axis and gimbal. What is gimbal? See, rotation axis we all know, that is X, Y, Z rotating, right? But what is gimbal? So to see what is gimbal, first we need to go and see. I'm just deleting this. Let this one be here. You can see this joint is getting rotated. You can see that I am rotating it in Z X axis, and this is Z axis, and this is Y axis. Okay, if I want to set a key pose, for this knee in first frame, I'm just setting the first frame. In some 20th frame, in some another 20th frame, if I want to make a different pose, I want to rotate it back. Okay, I want to rotate it back. Okay, see, for that I should go to front view. I should select, check for the axis, rotate Y. Okay, I'm just rotating it, but see, still it is not clear. Okay, I'm just going to see here again. I'm going to rotate it. I'm just keeping this pose, but this is normal selection. You can see, go to the selection tool and change into rotation. Double click on that. Then is object. So this orientation is according to this object. Okay, now I have taken very clear view, then I have given this adjustment. But instead of clicking on here, what will happen if I click here? You can see all my values are getting changed. Okay, so what is the problem here? I want to rotate only Y, but I am thinking that I am rotating only Y. But if I am deviating a little bit, my mouse jumps a very minute point little bit, every axis is getting changed and all the values are getting disturbed. So to overcome this problem, because when we create a rig for any character, the animator should be comfortable using that rig. The animator should feel comfortable in using the rig which we created. So keeping in mind all these things, I'm clicking here. It is a general tool for rotation. When I am going here and taking the toolbox again, changing this axis orientation from object into gimbal. In gimbal, see, now I am clicking randomly. What happens? The rotation in the world, okay, nothing is getting rotated, right? So if I click Y and I want to rotate, only Y rotates. And also it is clear that what is the axis that is being changed, the value of the axis that is being changed. Okay, now you can see Z. Okay, see, it is like you can see the rotation order in attribute editor. Okay, it is X, Y, Z. If you select Z, okay, you can see here, if you select Z, okay, X is also, Y is also being followed, and X is also affected, but X's value is not getting changed because exclusively we are not changing the X value, but X is a extension because the rotation order is from Z to Y to X. Okay, if you change the Z value, you can see Y is getting affected and X is also getting affected, but in this case the X practically it is not moving or rotating, so there is no change here, but you can see the chain. Okay, from Z axis the influence starts, it controls the Y axis, then comes to the X axis. Wherever there are possibilities for the changes to occur, that possibilities will take place. Okay, I just want to show what is the use of gimbal and how that rotation order will be, right? Z, Y, X. Okay, you can change the order also. Say for example, it is in gimbal mode. The main use of the gimbal is, see, you cannot rotate it other than clicking only on the axis. But if it is not gimbal, from anywhere you can control. Okay, and the main thing about gimbal is You cannot simply randomly rotate it and your key pose will be safe. Okay, this is the things about gimbal. Our next topic is FK and IK rigging techniques. FK refers to the term forward kinematics. To say it in simple words, FK refers to the effect on the child node as the parent node moves or rotates. See, it is the effect on the child as the parent moves or rotates. Okay, you know the connectivity or how the parent-child concept works. Okay, wherever the parent is, the child used to respond from its original place, right? So it is same like this. It is the effect on the child node, okay, as the parent moves. Okay, to explain it practically, to give the logical understanding, I am going to give an explanation with the help of the rig which already I have given. Okay, so in this rig, in mostly all the organic rigs, human or animal or whatever it is, in mostly in all the organic rigs, there will be two options for hands and legs. One is they can be applied with or used with IK method. Okay, this is IK. And the other one is FK. Okay, see, always there will be an option to switch between IK and FK. First, I will let you give some clarity. I will let you know and give some clarity about FK. Okay, I'm selecting this option here. After selecting this, when I'm coming to the option box, I can see, when I'm coming to the channel box, I can see IK FK switch. So if it is 0, it will be FK because already it is in IK and the value is 1. So I'm going to make it 0. And you can see the type of the controller has been changed. Okay, see, in this hand still it is IK, but in this hand it become FK. Okay, see what it is saying, effect on the child as the parent moves. Okay, so we will see it here. This shoulder joint is the parent. Okay, and this is the shoulder control, and this is the elbow control, which is the child of the shoulder. You can see it. If I select the shoulder, the child, following child node, I mean this elbow control is also getting selected, and if that is selected, this wrist control, WRIST, okay, wrist control or arm control, okay, this wrist control is also getting selected. So why it is hidden? Okay, why the movement or the translation is hidden? Because you cannot remove the shoulder from the body, so they have hidden the translation. Okay, translate XYZ, they have hidden it. Okay, so what is the main purpose in this FK? I can see the rotation. Okay, here whatever the change the parent node takes, that is followed by the child node. Okay, the child node gets effect when the parent moves or rotates. Okay, so you can see it. This is the child of this. Okay, and if I am moving it, you can see it is moving, right? But when a child moves, there is no effect on the previous node or the parent node. Okay, so to say in simple words, wherever the parent node or parent control starts, from there the influence travels forward. Okay, from there the control or the influence travels forward. Okay, from here to here forward, here to here forward, and this is the end. Okay, so here we can see this is the root or the base for the shoulder, sorry, for the entire hand. The shoulder is the root, or you can say it as the base. So this base continues to the elbow and from there it goes to the wrist. So from here to here to here, okay, the effect is taking place. From shoulder to the forward, okay, go forward, go front, go forward, right? That is elbow. It is affecting the elbow, and from elbow go forward, okay, what is there? It is the wrist. So the elbow is affecting the wrist. So this is practically how to understand the logic of the FK control. Okay, why do we need to have this FK type of controllers? The thing is, when the body is in complete motion, okay, say for example the entire body of the character, if it is in the air, okay, see, I'm just going to select the base control, select the hip control, I'm going to pull it. You can see the FK control structure travels along with the root, okay. This is the forward from here to here to here, and this is a child of a parent which is called shoulder. So wherever it goes, it may go, okay, or this can be connected to anywhere in the part of the skeleton, right? But what happens in IK? In inverse kinematics, it is called IK, inverse kinematics. See, here is the root. From there on, from here to here to here, the control or the power should travel. But here in FK, the shoulder is the controlling person. But here in IK, the child controls the parent, right? You can see in inverse kinematics, how it works, it's how the child node as it moves affects the parent's orientation values. Parent's orientation means rotation or movement values. Here we have rotational option only, okay. See, say for example, if I'm moving this in IK and I'm rotating this, sorry, I'm moving this, you can see the shoulder rotation is happening, right? So the child node affects the parent node. That is in case of IK. Here the power or the commanding authority is IK. IK will not obey wherever the parent goes, okay. Wherever the root or parent goes, the IK will not follow that. IK is an independent acting technique, okay. It can be independent and it can be given to any part of the body, but it should be practically acceptable, right? See, in this way the arm works, so the IK can be given. So like this, see, for the foot it is IK. So we need to see the logic, okay. Wherever the child makes changes towards the parent, there it can be applied. Which one? The IK. So here, why do we need FK again? Yeah, I told you, whenever the body is or the rig is completely in the air. So we can have a small example. Say again, I'm changing FK control here, okay. So now both the arms are in FK. Say for example, my character is flying, okay. My character is flying, right? My character is flying or something like that. I'm just giving some position like that, okay. Or the character is falling down, right? So for that If it is IK, the hand would have been stayed here. That is no problem. We can still bring it and here and keep the pose, but the flexibility of the elbow, okay, like to make it to feel like a bird, okay, that flexibility cannot be achieved. Okay, see, because it is not possible for a human to fold his hand in a back way. I mean, it is like you cannot fold your arms like this, okay, practically. In IK, this pose cannot be achieved. But still in cartoons, we don't follow this kind of practically possible mechanical poses. We will simply go through whatever is given in the storyboard. Okay, we can bend or make the character to animate like a thread or whatever it is. We can loosen the character. We need not to stick tightly with the body mechanics. Okay, we can break the anatomy and animate for fun. So this can be achieved only through FK. See, so I'm just going to show you a small example. Say for example, I'm just taking some 20 frames. Okay, so in this my first frame, I'm giving set key here and set key here, and in my 10th frame, I'm just moving it up. So in my first frame, I'm going to select the IK handles. Okay, I'm going to rotate it to upwards and set key, and I'm going to copy it to the 20th frame, set key. In the 10th frame, I'm going to rotate it inwards and set key. Okay, so for these kind of actions, see, even I can make it more flexible with the help of this controls. Okay, this controls, actually I didn't give any key. I'm going to give set key here in 10, 1, 10 and 20. Okay, here again in 1, I'm going to make it still more flexible. Going to copy it here. In here, I'm going to make it little bit inside. So here I'm going to show only the polygons. Okay, so this is just for an example. Okay, right, just to understand why FK is needed and why IK is needed, I will tell another show another example why IK is needed. This is the need of FK, right? So I will show why the IK is needed. Okay, now again coming back, I'm going to change everything into IK. Select this, going back here, change everything into IK. Again, I'm going to change this arm, this control, I'm going to change into IK. Okay, now both the hands are in IK. How IK can work possibly? See, I'm taking a cylinder. Okay, see, now the character should have a pose like it should be standing somewhere balanced. Okay, so in this pose, I'm keeping the hand here, giving set key, I'm rotating it. Okay, I'm rotating it a little bit. I'm rotating the finger control also. I'm rotating bringing the fingers up. Here also I'm selecting, bringing the fingers up. Okay. Right, now see, this is the child practically, but it won't follow the parent. Now the parent should follow this. See for example, now it is like I should have a balance here. Okay, so I have given a balance for this character to stand near this pillar. So say for example, if I'm giving key to the hip, again I'm giving the same pose. Now I'm just moving to the normal pose. Okay, I'm just bringing it down. So this character is doing some exercise. See. So this is all what practically we use IK and FK in different kind of animations. Wherever it is possible or wherever the need occurs, there we should switch to either IK or FK. Okay, this is the difference between IK and FK. And what is animation controller? Yes, you know very well, I think. Animation controller, these are the animation controllers. Mostly animation controllers are created using the curves. Okay, you can see curves here. You can see curves here. In curves you have circle, nerve, square and everything, but mostly we will use circle, and we will alter the circle. We will make the circle into different shapes to differentiate between different joints where the controllers are attached to. In this joint, for the wrist joint, the controller should be like this. For the knee joint, I mean the pole vector, the controller curve should be like this, because we should follow a uniform design language in creating controllers. Okay, see this pole vector or the knee control, it looks in the arrow shape. For the leg, same thing it looks for the hand also. Okay, so we should follow a similar design pattern when creating controller curves, and these curves are not visible in your render view. Okay, that is the main reason we are creating animation controllers using curves. If it is a polygon or if it is a mesh, whatever, any kind of mesh, it will be visible in your render view. Okay, curves are not visible in rendering, in render mode. So it will be easy for us to take render outputs without turning off curves each and every time. Okay, so that is the main purpose of creating animation controllers using curves. And see, the other thing is skinning. I told you, right, the skinning is a process of binding joints and bones with the mesh. It is mostly used in organic rigging. I will show you with a small example. Okay, I will take 3 parts. Okay, I will create one IK setup. I will tell you how to create a IK handle and how to create animation controller, and how to attach the animation controller with the IK handle, and how to create a mesh. I mean, it is a simple mesh. Okay, you know very well modeling. So how to attach this skeleton setup which is with IK rigging with the skinning. Okay, first we will create joints and bones, then we will create what, IK handles, then we will create animation controllers, then we will do skinning. Okay, I will show a very small example which will be very easy for you to understand. Say for example, if this is a human arm, okay, this is a human arm, right? So a human arm works in this way, right? So we will take three joints, three simple joints. We will apply the IK handle first, then how it works we will see it. Okay, we need to achieve, our target is to achieve this kind of action. Okay, so shoulder, elbow and wrist. Okay, so three joints we need to create. Within the three joints, one bone, shoulder to wrist, shoulder to elbow, bone number 1, elbow to wrist, bone number 2. So three joints with two bones we are going to create, and we are going to achieve this action with IK. Okay, so let us all open Maya. As I told earlier, come to either front view or right view. Okay, come to any graphic view. Do not try to create joints or bone in a perspective view, because it will get placed somewhere randomly in the Maya workspace. So I'm going to change it into rigging. Already it is in rigging. Now I'm going to take the rigging tab. I'm going to take create joints, open the joints, reset the settings every time, come to front view. So we are going to create similar thing. Okay, something like we are going to try to achieve shoulder, elbow, wrist. Okay, shoulder, elbow, wrist, enter. Okay, one more thing, when I click on this joint, if I go closer, see, for me it is coming clearly, but in case if you are facing issues like this, like what, see, when you select a joint you can see something called radius. It is 0.6 for me. Okay, and what if happens it is 1, you can see the radius size is bigger. What happens if it is 2? See, the radius of the shoulder joint is too big, so that the bone is looking very small, or the distance between the elbow and the shoulder looking very small, or it is not at all looking like a human arm structure. So this may happen. Okay, so to clear that problem, initially, before creating, I'm just deleting it again, before creating it, go to the tool settings. There you can see the short bone radius. Okay, you can increase or decrease, right? You can set this value, then you can have a decent size or what, a constant size of a bone structure. Okay, I'm just going to create shoulder, elbow and wrist, give enter. Now I'm going to give proper naming. Okay, now what is this called? Shoulder joint, elbow joint, wrist joint. You may ask me one question. Why do we need to give naming for this joints? See, for example, if you are having a human rig like this, which is having many number of joints. See, it may be maybe around 50, 60, 80, 100. That may depend on the complexity of the character model. So for that, there is a part called paint weight tool. Okay, we will get to know about that in future. So when we are using that paint weight tool, we need to select each and every joints separately. Okay, if you are not giving proper name, see in this outliner I can see shoulder, elbow and wrist joint. If you are not giving proper name, it will come joint number 1, joint 2, joint 3, like those joint 50, joint 60 will be there. So you don't know to select which joint, if either it is a hip joint or it is a chest joint. So to get clarification, we need to give proper naming, right? Now I am going to give IK handle. We are going to create this as a IK arm. Okay, IK human, IK arm, IK hand. So for that I am going to create a IK handle. See, here you can see the IK handle tool. Double click on that. Before creating an IK handle, we need to select two options will be there: single chain solver, rotate plane solver. See, we should check if it is in rotate plane solver or single chain solver, because if it is a single chain solver, you cannot give constraints like orient constraint. Orientation is what? Rotation. Okay, you cannot give constraints like orient constraint. It cannot rotate. It is a single chain. It can move, okay, but it cannot rotate. So for that purpose of rotation, for the arm we need to give rotate plane solver. Wherever the IK handle is being applied, make sure there and all you need to give only rotate plane solver. Okay, click on rotate plane solver. See, what is about this option sticky and auto priority, that and all we will see in our next classes, upcoming classes. So make it rotate plane solver. I'm just going to click on the shoulder, again click on the wrist. That's all. You can see the IK handle is created. You can see the IK handle, how it works. Okay, see, shoulder is the parent. That is where I clicked first. Okay, where I clicked last. My first click should control, but it is not, because it is IK. The child will only control the parent, right? So it is happening very clearly. Now it is controlling the parent. Okay, so go back to your outliner, or you can take it here itself. In IK handle, you just give the name, right arm or left arm. I'm just giving right arm or right hand. Okay, just for a clear understanding, right hand IK, right hand IK handle. Okay, that's it. It is good, clear. Okay, we have created joints, bones, and we have created IK handles. Now what is pending, which is animation controller. We need to create animation controller and we need to do skinning. So for that, first I am going to create an animation controller. Okay, how to create an animation controller? It is very simple. Go to curves, create a round curve. You can see a curve has been created in the ground. You can simply bring it here. How to snap it exactly? See, you can go to perspective view. I want to make it exactly in the middle of here. Okay, somewhere in middle of the, exactly in middle of the joint. Okay, but it is not possible. Okay, how to achieve it? That is very simple. Come to again front view. I'm just taking this controller. I want to align it exactly to the center of this joint. Okay, so what am I doing is going to the top and I'm checking for this option, snap to grid, snap to curve, snap to point, snap to center, snap to plane. Okay, so I'm going to click turn on snap to point. I just turned on snap to points. Now I'm going to select this. If I'm going to try to move it, automatically it will snap to the nearest point, nearest center point of any node. See, now if I select this joint, the pivot of this joint, the pivot point or the pivot point of the joint is exactly in center. That is its original pivot. And now if I select this control curve, animation controller, its pivot is also taking the same value of the joint. So snap to point, so this is, the snap to point will attach, or it will snap to the nearest point of any node. Okay, anything, it's called as a node. Okay, the joint is a node, right? So that's all. But what happens here again? Still I cannot move it, right? What will happen? What should happen? It should be independent. Again, I'm going to the top, turn off this snap to point. Now if I wish to move this, it won't automatically take control. Okay, to take control, what should be given? Parent-child relationship. Either it may be a parent-child concept or constraining concept. Okay, see, when the rig is very simple, or you are going to attach multiple number of meshes in a simple way, we can use parent-child concept. But when it comes to complicated rigs or advanced rigs, we had multiple types of constraints which are meant for specific options, specific usage. Parent is for moving and rotating, point is only for moving, orient is only for rotating, right? So for that we need to find the purpose of the relationship between this controller and this IK handle, because this joint is now being, it is not what, independent, it is now being attached to the IK handle. IK handle is the controller, so we need to give connectivity or relationship between the controller to the IK handle, not to the joint. Okay, so what will happen if you connect this to this joint? If you move this may move. Okay, but it is not a right way, right? So here, who is the master controller? IK handle. So I'm just going to connect this controller with the IK handle. But I hope you remember, I told you, whenever you are creating any connectivity, any connections, parent-child or constraint, you need to make sure the global value or of both the elements, or at least one of the elements, or at least the child, should be 0. It should not have some random values like this. Because when I created this curve, it is somewhere else in the ground level. When I moved it and snapped it here, you can see the values are changed. So if I give this kind of value, what will happen? If I want to move this to the top, I will move. But when animating, I want to make it back to the 0th position, back to the bind position. What I will do, I will not adjust it manually. I will simply go here and give enter 0. Yeah, I will give 0 and enter. Okay, right, but it is not going to applicable for IK. So what will be the controlling point? The controller. Okay, if the controller already it is having some value like this, with this value, when I create connectivity and it goes up and down, after that I want to make it to a 0th position, if I give 0 here, it will go from here to here, the ground position, because it is the original 0 value of this controller. Okay, so if I want to make it stay here in the original position, then I should give 0, then it should stay here. For that we need to make this 0 by keeping it here. How to achieve it? By simply going to modify and freeze transform. Okay, now you can see everything is 0. That's all. Good. So in this part, what am I going to do? I'm going to move my arm. I'm going to rotate, but rotating is practically not having any effect, because IK handle, there is no output of rotating. It is not FK. It is not forward motion. Okay, so it is simply moving up. So for that, which connectivity, which constraint will help us? I want to simply move. Parent constraint, it is for rotation and moving, translation. Only for translation it is point constraint. But you will be having a question. Okay, what is that question? Here we have only shoulder, elbow and wrist. But what about the palm and what about the fingers? Okay, if we have a palm and fingers, then it should rotate, right? Yes, good question. But still the IK handle takes effect only from here to here. Okay, from elbow, sorry, wrist to shoulder. It won't extend its influence over the next joint. Okay, so for that we need to work with the connectivity of the next joint or the next bone and this controller. This controller and that bone should have some connectivity, not the IK handle. So for this IK handle we are going to have only the point constraint, which is the movement, right? So how to do it? Select the controller, shift select the IK handle, go to the constraint, open point constraint, check for maintain offset and give apply. Close it. Okay, now you can see my animation controller is controlling the IK handle. Why do we need animation controller? Because the animator will not select the IK handle and move, and he will not use this kind of technical things to give set key and make key poses. Okay, so that is why we need animation controllers, and our animation control is working very fine, very well. Now the pending part is skinning. I'm again coming back to the front view. See, I'm going to create some mesh like thing. Okay, see, I'm taking some cylinder. I'm taking a cylinder. I'm making it lengthy enough to match this hand. Okay, press 4 more. Okay, this length is matching exactly with my arms. Okay, I'm going to reduce a very little bit. Okay, now I'm going to select the vertex. Oh sorry, I'm going to object mode. I'm going to this inputs, and I'm going to increase the height. It is 2, the height is 2, 0, sorry, 1 and 2. I have to increase the height. I'm going to increase the subdivision height. Subdivision height is 0 to 1. Okay, now I'm going to increase it because I need a curve here. I need a bend here. Okay, it is shoulder, it is wrist. I need a bend here. Okay, I'm just going to make one more curve. So I'm going to make the vertices, move it like this. I'm going to take this object and move it here. I'm going to take the vertices. Here, select the vertices, bring it down. I'm going to squeeze it a little bit. See, this is just for understanding. Okay, this is not actually a model. I know you are very good in modeling. Okay, I'm just matching it. In my front view, it is matching. Okay, go to perspective view. Okay, because mostly in perspective view, it may be here or here. Okay, but for me, it is exactly matching in perspective view also. I'm going to perspective again. I'm just going to show you how to do skinning. Okay, skinning in the sense attaching the bone structure or the skeleton structure with the skin or the mesh. Select the root joint or the base joint. Okay, only the influence can be from IK handle from this place, but basically this is the root from where we created. This is the root joint or the base joint. Okay, so take that and shift select this mesh and go to skin and open bind skin, reset it. Okay, give the option bind skin. Okay, now the connectivity between the bone structure and the skin has been done. Now let us check. I'm going to turn off everything, show none. I'm going to turn on only the nerves, curves and the polygon, because I don't need what is inside the bone or the IK handle. I don't need all these things. Okay, so I'm just coming here. I'm going to check. Yeah, my hand is working. Okay, my hand with IK control, it is working fine. Okay, right? It is a very simple model. In our next class, we will see how to use multiple types of constraints within a single IK handle. Okay, so for that we are going to take a reference of, yeah, this is also a IK handle. Hope you understand. Okay, IK handle can be set for this one also, but in a different way. And we need to have, we have point constraint here, and we need to have orientation constraint here. We need to have pole vector constraint here, and we are going to have aim constraint for the switching, right? So we will be trying to apply all the type of constraints within this simple model, so that it will be very clear for you when you are start doing the next rigs like humans and animals like that. Okay, so I hope up to this it is very clear and easy for you to understand, right? So, and we had a clear understanding about IK handle, animation controller, skinning, what is the need of gimbal and joints and bones and all these things. So I hope you are all having this file. With this topic, I'm closing today's session. You can ask me for doubts in the class. Okay, for the next class we will see how to rig the table lamp with multiple types of constraints applied within one IK handle. Okay, so please concentrate and learn this well. The next class will be a little bit more technical. Thank you.